Okay, so we're going to be starting lesson 4. That's our solving radical equations. So if you look at our unit, we're about halfway through. We have 2 more essential questions to go over. This folded region here, make sure you read through that. That's what we're learning this week and what you need to be able to do by the end. For this lesson, day 1, you need to be able to solve these equations that are involving our radicals. Remember, that's our symbol with our radicand, like so. We need to be able to recognize the difference between our radical equations and our functions. And then we need to make sure we're using that proper vocabulary when we're describing these. So saying the nth root of whatever we're saying, of whatever we have in our equation. So we would say the nth root of x if I had nth root of x. If it was raised to a power, say it was to the 10th power, we would say of x raised to the 10th power, or raised to the power of 10. IRS, these are what we use to remember our steps. So remember, first step, we're going to isolate. Next step is to raise each side of the equation. So that's a big, long definition. That's not going to help you remember it. I recommend just remembering raise to the nth root. So, last thing you need to solve, and make sure you're checking your solutions. Example 1. It says solve the following radical equation. What we need to do is determine what part is our radical, so don't forget. I'm going to go through and box these. I recommend doing so as well if you struggle knowing what to get rid of first. Your box will always end right after that bar on the top of the radicand ends. So that means we need to get rid of this 2. We're going to be dividing by 2 on both sides. That gives us a square root of x plus 1 is equal to a 2 now. Well, if we look here, our n, we don't see an n here. Whenever we don't see an n, we assume it's a 2. So 2. That means I put a 2 here and here. Our exponent, we're raising it to that nth root. Our n in this case was a 2. Those are going to cancel each other out, leaving an x plus 1 behind, which is equal to a 4. Subtract your 1 from both sides. So we should have an x equals 3 here. Now to check your answer, over on this side, square root of a 3 plus 1 equals 4. Then we have the 2 in the front. So if I have a 2 times the square root of 4 equals 4, well, 2 times 2 equals 4. That checks out. So we've done this correctly. We found our solution. For our next problem, we have a cube root of a 2x minus 9 minus 1 equals 2. So what I'm going to do here, once again, I'm going to box that radical. It ends right after the 9 because that's where the radical ends, right here. So that means I need to get rid of this negative 1. So I'm going to add 1 to both sides here. So these a cube root of a 2x minus 9 is equal to 3. What we're going to do is we have this 3 here this time. That means I'm going to use a 3 on each side to raise this to the power. When I raise this to the 3rd power, those cancel each other out. So this is a 2x minus 9 over here. And that's going to be equal to a 27. Now I'm going to add 9 to both sides. You're going to solve this using your regular PEMDAS. So we add that 9 in, we're going to get to a 36. Divide by 2, we end up with x is equal to an 18. When you plug this back in, you have the cube root. Well, I'm going to have that 18 now, so 2 times an 18 minus 9 minus 1, and that all needs to be equal to a 2 here. When we combine this, we'll have a 36, so we have the cube root here of a 36 minus 9 minus 1 equals 2. 36 minus 9 going to be the cube root now of a 27. Cubic root of 27 is 3. Well, 3 minus 1 equals 2, so everything checks out. We found our solution correctly. At this point, you should pause the video, and you need to complete the 3 practice problems to the right here. Should take about 8 minutes at the most.